So in assignment number 7, we're going to be multiplying, dividing, and then putting numbers in order that are in scientific notation. So let's go ahead and get started. We have some real-world applications here to think about. I don't know if you've ever heard of a light year, but a light year is a distance that light travels in a year. So if you go out late at night tonight and turn on your flashlight and shine it up in the sky, in 1 year, those light rays will be 5.9 times 10 to the 12th miles away. That's quite a distance, but let's see if we can use that to answer some questions. Suppose that we have a certain star that is 8 light years away. So how many miles is this? We want to write our answer in scientific notation and as a regular number. What that means is we're going to take 8 times the 5.9 times 10 to the 12th. So we're going to multiply the 8 times 5.9 first, and 8 times 5.9 is 47.2, and then we have times 10 to the 12th. So this is a correct answer, but it's not in scientific notation because the decimal is in the wrong place. Right now we're going to take the decimal and move it 12 spaces to the right, which is this direction, but we want to write it as 4.72, which means we want to put the decimal back here. So when we multiply it times 10 to a power, we're going to have to multiply it times 1 plus the 12 spaces that is already designated up here as to the right. In other words, we're going to multiply it times 10 to the 13th power. And so in scientific notation, it's going to look like this. And what does that look like as a regular number? Well, we're going to have the 4, the 7, and the 2, and we're going to start with the decimal here and move it 13 spaces to the right. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces, which means we're going to add these 3 zeros and 3 more zeros, 3 more zeros, and these zeros. So this is the ones period, the thousands period, the millions period, billions, and trillions. That's 47 trillion, 200 million miles away in 8 years. And so we can extend this to a question that looks like this. Let's say that there's a more distant star that's 3.6 times 10 to the 5th light years away. Well, just like we multiplied the 8 times 5.9 times 10 to the 12th, here we're going to multiply 3.6 times 10 to the 5th times the 5.9 times 10 to the 12th. And so we have two numbers here that we're multiplying in scientific notation. And so that means we're going to start by taking the 3.6 times the 5.9, and 3.6 times 5.9 is 21.24. 21.24. Then we're going to multiply that times 10 to a power, but to get to that power, we're going to have to take 10 to the 5th times 10 to the 12th. And because those are like bases, we're going to add the exponents. That's 10 to the 17th power. And so that means that that planet is 21.24, or that star is 21.24 times 10 to the 17th miles away. And as a regular number, again, that's not in scientific notation. In scientific notation, we would write it as 2.124 times 10 to the power. So if it was written like this, we'd have to move it 17 spaces to the right. But if I put the decimal here, which is where I want it, it's going to be 1 plus the 17, which is going to be to the 18th power. And so in scientific notation, it's going to be 2.124 times 10 to the 18th power. And that's going to be substantially even more than what we had here. So let's go ahead and move on. It says to write it as a regular number also, which we could do, but I'm going to skip that at least for this video. Okay, so here we have a planet Pluto that it's not really a planet anymore, I guess, but it's a 45th of a light year away. So that means we would take a light year, which is 5.9 times 10 to the 12th power, and divide it by 45, and that's how far away Pluto is. Now, Pluto varies because it's orbiting around the sun, and so is the Earth. So its distance from the Earth is varying, but at some point it is this far away from Earth. And so if I take 5.9 times 10 to the 12th and divide it by 45, I can start by simply taking 5.9 divided by 45. So if I take 5.9 divided by the 45, that's going to be 0.1311. 0.1311. And then I still have times 10 to the 12th power. Now, this is a correct answer, but it's not in scientific notation. I would want to put it as 1.311 times 10 to a power. If the decimal is here, I'd have to move it 12 spaces to the right. But if I put the decimal here, then I'd only have to move it 11 spaces to the right because I would already have it one space closer to where I need it to be. And so that means Pluto would be 1.311 times 10 to the 11th power. And so we could write that as a regular number as well. Let's go ahead and move on here. National debt. At the beginning of Donald Trump's presidency, the national debt was 19 trillion. Actually, this is the ones, thousands, millions, billions, 19 trillion, $190 billion. That was by far the highest that the debt has ever been. There are also 325 million people living in the United States. And so let's suppose that we decided that we were just going to pay off the national debt. Everybody just pays their the same amount, and as soon as everybody pays their same amount, we'd have a debt of zero. Well, how much would each person have to pay? Well, in order to answer this question, we're going to have to put both of these in scientific notation, or at least that would be one way that we could do it, at least so that we can use our calculators. The national debt is 1.919 times 10 to a power. That would mean the decimal has to be here, and we'd have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces to the right. So there's our national debt, 1.919 times 10 to the 13th, and we're going to divide that by the number of people, which is 3.25 times 10 to a power. If I put the decimal here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right. And so we're just going to take the amount of money that we owe as a country divided by the number of people in our country. And so we're going to start by taking the 1.919 divided by 3.25. And it's not exactly, but it's really close to 0.59. So I'm going to take the 0.59 times 10 to a power. And so that means I'm going to take 10 to the 13th divided by 10 to the 8th. And if you remember the quotient property that we did yesterday, we're going to take 13 minus 8 because they're like bases. 13 minus 8 is 5. And so that's 0.59 times 10 to the 5th, although that number's not in scientific notation. If we wanted to put it in scientific notation, we'd have to write it as 5.9 times 10 to a power. If the decimal stayed here, I'd have to move it 5 spaces to the right. But if I move the decimal here, that's one place closer, so it's going to be times 10 to the 4th power. This is what every person in the United States would have to pay in order to pay off our national debt. Well, what does that look like as a regular number? Well, here's the 5 and here's the 9. And we're going to move the decimal 1, 2, 3, 4 spaces. That means every single person is going to have to pay $59,000 in order to pay off our national debt. And so that's including everybody, including 2-year-olds and 82-year-olds and everybody. You would have to pay your share, which would be $59,000 to pay off our national debt. So that's a lot of money. So another example. Suppose that I do have 2 sons, and suppose I'm going to leave them both a sizable inheritance. My youngest son, Jacob, suppose he gets 2.5 times 10 to the 6th power. And my other son, Zach, gets 2.5 times 10 to the 5th power. So who will get more? So it's obvious by looking at the exponents here that Jacob's going to get more. But by how much? And so we could look at this 2 different ways. There's an easy way to do this, but the long way is this. If you look at Jacob's amount of money, it's 2.5 times 10 to the 6th. That means it's going to be 1, 2, 3, 4, 5, 6 spaces to the right. That means that he would get 2,500,000. Zach, 2.5 times 10 to the 5th would be 1, 2, 3, 4, 5. Zach would get 250,000. So how much bigger is 2,500,000 than 250,000? Well, it's just like knocking off a 0. And when you knock off a 0, it's like dividing by 10. So this would be, who would get more? So Jacob would get more, and it would be 10 times more. Every time this number goes up by 1, it's going to be that many times bigger. So if, let's say, Jacob got 2.5 times 10 to the 7th, it would be 10 times 10, or 100 times more than what Zach would get. This number makes a big difference on ordering those numbers. That's what our homework assignment is going to be on. Multiplying, dividing, ordering numbers that are in scientific notation. And so that's what we're going to be working on in our homework. Good luck with that. And we'll go over questions that you have in class tomorrow.